In the quiet between the planets, something is moving, not just drifting, but changing. Astronomers call it 3i Atlas, the third interstellar visitor known to cross our solar system. But unlike the others, this one carries a secret. Its tail doesn't follow the light it faces toward it. Against the wind, against the rules of nature, and no one, not yet, knows why. In early July, scientists believed it was another comet, one of the countless icy travelers that fall toward the sun each year. But the data came in quickly. Its velocity, more than 26 kilometers per second relative to the sun, was far too high to be bound by gravity. It wasn't from here. It couldn't be captured. It was just passing through. The name came later. 3i Atlas, discovered by the Asteroid Terrestrial Impact Last Alert System, a network of robotic eyes scattered across Hawaii, Chile, and South Africa. The system was designed to warn Earth of oncoming threats. Instead, it found something that made astronomers stare in disbelief. Like a ghost, 3i Atlas arrived from the direction of Sagittarius, the region that points toward the center of our galaxy. Its orbit cut through the ecliptic, the plane where all our planets dance with unusual precision, almost as if it had chosen the route. Comets don't usually do that. They come in at wild angles, plunging from above or below the plane of our solar system, relics from deep space or long-forgotten reservoirs. But this one seemed oriented, and that's where the whispers began. At first, the anomaly seemed simple, a backward-pointing tail. Normally, a comet's tail is blown away from the sun by solar wind charged particles streaming outward at hundreds of kilometers per second. The geometry is straightforward. Light and heat cause the ice to sublimate, and the gas trails away. But 3i Atlas did the opposite. Its faint emission appeared to stream toward the sun, not away from it. That kind of behavior demands explanation and fewer comforting. One possibility, a strange dust structure, perhaps a dust fan shaped by rotation. Another, a burst of asymmetric gas jets pushing the material in unusual ways. But there was a third hypothesis, one that brought back an old debate that began 7 years earlier. In 2017, the first interstellar object, Oumuamua, streaked through the solar system. It was small, bright, and accelerating ever so slightly without a visible tail or engine. Harvard astrophysicist Avi Loeb suggested it could be an artificial object, a fragment of alien technology, perhaps a light sail powered by starlight. The scientific community mostly dismissed the idea. Too speculative, they said. Too soon to claim such things. But with 3i Atlas, the pattern returned, and so did the unease. Because this one isn't small. Its nucleus could be tens of kilometers wide, far larger than Oumuamua, and covered with carbon-rich dust. The data suggests that it is active venting material, but doing so in ways that don't match solar heating patterns. When astronomers plotted its outgassing rate, they found irregular surges, as if driven by hidden mechanisms or varying internal power. To understand this behavior, we must ask a dangerous question. What if some of these interstellar objects are not natural at all? Imagine a civilization far older than ours, one that mastered interstellar travel not with engines, but with patience. They could send small, durable probes into the void, letting them drift between stars for millions of years, awakening when they sense energy. Our sun would be such a trigger, a bright flare in their long, cold journey. And perhaps that's what we're seeing now, not a rock, but a seed. A messenger designed to bloom in the presence of light. Of course, such ideas live at the edge of science. But even conventional models strain to explain 3i Atlas. Spectroscopic data shows a high CO2 water ratio, meaning its ices are different from most solar system comets. It carries more frozen carbon dioxide than expected and less water, a signature that suggests formation around a different kind of star, a colder star, a dim red sun. It may have formed billions of years ago in a disk unlike our own, then been ejected perhaps during the violent birth of planets and set loose to wander. After untold eons, it finally crossed paths with us. That's the romantic vision, a time capsule from another world. But the numbers hint at something stranger still. Its trajectory, nearly aligned with Earth's orbital plane, gives us a rare chance to observe it up close. If it fragments or flares, we may capture its inner structure with the James Webb Space Telescope. Avi Loeb and his team at Harvard have already submitted proposals to study it. Their reasoning is simple. We may not get another chance for decades. The last visitor, 2I, Borisov, passed in 2019, a more typical comet, rich in cyanide and dust. This one is different, cleaner, sharper, too orderly in its movement to dismiss outright. When an object from another star enters our system, it's more than a celestial event. It's a message written in the physics of motion. Every deviation, every jet, every brightness change tells us something about its origin. Was it formed in the same kind of nebula as Earth's building blocks? Or does it come from a realm where chemistry and perhaps even biology took another path? Already, some simulations suggest that the Milky Way may be filled with trillions of these objects drifting between stars. Most are dark, silent, unseen, but occasionally one crosses the thin circle of sunlight that we call home, and each time we're forced to look outward and inward. If 3I Atlas behaves like a normal comet at perihelion, if its gases release in predictable waves, we'll classify it, file it away, and move on. But if it changes course, if it accelerates without clear cause, if it maintains structure while passing near the sun, then the conversation changes. Because at that point, we would be looking at an engine, not a natural one, but a designed one, something built to endure, to maneuver, to observe. And even if it's not, the possibility alone is profound. Consider the implications. If interstellar space is seeded with such objects, then the galaxy could be alive with messengers, artifacts of civilizations that no longer exist, drifting between stars like dandelion spores, silent until light awakens them. Maybe that's the meaning of 3I Atlas, not a weapon, not a warning, but a whisper. A sign that intelligence once born refuses to vanish completely. Even in ruin, it leaves traces. Right now, as you listen to these words, 3I Atlas is hidden behind the sun, invisible to our telescopes, but still there, crossing the space between Mars and Venus. When it re-emerges in late October, every major observatory on Earth will turn toward it. NASA, ESA, and amateur astronomers alike will try to catch its reappearance to see whether it brightens, fades, or disappears entirely. And as it does, humanity will again ask an ancient question. Are we alone? Not in the poetic sense, but in the literal, physical, data-driven way. Because if we are not, then this object is not just a comet. Its contact subtle, slow, and silent. The kind that arrives not with sound or message, but with mystery. We have always imagined first contact as noise, a broadcast, a signal, an unmistakable shout across the void. But perhaps that's not how civilizations speak. Perhaps they leave artifacts inert, quiet, patient. Perhaps the universe itself is a museum of lost intentions. We may be looking at one of its exhibits right now. Whatever it is, 3I Atlas challenges our understanding of cosmic migration. Its composition, its unusual dust structures and trajectory remind us that we've barely begun to explore the diversity of the Milky Way's debris. Each interstellar visitor carries the fingerprint of its birthplace. Each one is a messenger from a different chemical language. By studying them, we're not just learning about rocks, we're reading the autobiography of our galaxy. But the real power of this discovery isn't in its mystery, it's in what it demands of us: curiosity without conclusion. To look without claiming, to measure without assuming, to wonder without worship. Because 3i Atlas may be nothing more than ice and dust, or it may be something that rewrites our cosmic story. Either way, it's a reminder of what it means to explore. In the end, we are all travelers between stars, fragments of dust, bound by gravity and imagination. And when something from the dark comes to meet us, the least we can do is listen